I'll bet you've noticed that your approach charts have much of the same information that's in the airport facility directory. Communications, ATIS, AWOS, or ASOS frequencies, runway data, and lighting information are all on the approach chart, and they're arranged in the order you need them. But does that mean you can chuck the little green paper back and free up some space in your flight bag? Not by a long shot. There are some things that the approach chart just doesn't have room to tell you about. For openers, remember the little star that you sometimes see next to a frequency on an approach plate? Suppose you're planning a flight to Miami's Opa-locka Airport and you don't expect to arrive until around midnight. When you look at the ILS runway 9 left approach, you notice that the tower frequency has one of those stars. As you already know, that star means the tower does not operate continuously. But where do you find the exact hours of operation to find out if the tower will still be open when you arrive? Well, you look between the little green covers of the airport facility directory at the Opa-locka entry. When you look down the page at the communications area, you see that the tower only operates between 1200 and 0200 Zulu. To find out if the tower will be open, you need to convert that UTC time to local time. By the way, notice that little plus over plus symbol at the end of the entry? It means that during daylight saving time, the hours of operation will be 1 hour earlier than shown. Why? Well, when you move the clock ahead 1 hour in the spring for daylight saving, you still keep doing things at the same old time. If you're supposed to start work at 8 a.m., you still start work at 8 a.m., whether you're on standard time or daylight saving time. And that applies for the folks in the tower, too. Let's assume it is daylight saving time, so the tower will operate from 1100 to 0100 UTC. The time conversion to local time is on the top line here. It's -5 hours during standard time and -4 hours during daylight saving time. Since it's hard to subtract the 4-hour time conversion from the closing time of 0100 UTC, first add 24 hours to 0100 to get 2500. Then subtract the 4 hours. That means the tower will close at 9 p.m. local time and will be closed when you arrive. But facilities like the tower aren't the only things that have limited hours of operation. For instance, right below tower, notice the remark that Class Delta airspace is effective 1200 to 0200 Zulu, which is when the tower is operating. Not only will the tower be closed when you arrive, you'll be making your final approach into uncontrolled airspace. Good to know. Now, drop down here toward the bottom of the entry. Let's find out what precision approaches are available at Opa-locka. The first thing that you notice is that on runway 9 left, the localizer is not monitored when the tower is closed. That means that if there's a problem with the localizer signal, no one will be able to tell you so in advance. You'll discover it when you try to shoot the approach. Notice that runways 27 right and 12 also have ILS approaches. All in all, lots of information of value when you're planning an instrument flight. Now let's take a look at some parts of the airport facility directory that you may not have noticed before. You know that where traffic is heavy, ATC can smooth things out by having traffic flow through specified routes called departure procedures and standard terminal arrival routes. When traffic is busy enough between two airports, ATC establishes specified routes that connect the DPs and stars. These special routes are called preferred routes, and they're listed in the back of the airport facility directory. Let's see how one of these routes works. For instance, between Opa-locka and Tallahassee. Flip toward the back of your airport facility directory to the section titled Preferred IFR Routes, Low Altitude. Under Miami Metro Area, find Opa-locka OPF as your starting point. Then run down the list of terminals and find Tallahassee. There it is. And there's the preferred route. Dolphin, Victor 97, LaBelle, Victor 157, Lakeland, Victor 7. Since the preferred route begins with a fix, you can expect to get there either by radar vectors or a DP. The Tallahassee end saying just Victor 7 seems a little ambiguous, but the initial approach fixes for the approaches at Tallahassee are located on Victor 7. If there is a star at your destination, the preferred route includes it. Take a look at the entry for Tampa here, right below Tallahassee. The preferred route ends at the bridge star. If there is a preferred route between your departure and destination airports, you don't have to use it when you file your flight plan. But if you do file it, it will make both your job and the controllers easier. And you'll minimize the chances of delays or surprises when it's time to copy your clearance. Now, something similar to the preferred routes is Tower En route Control, abbreviated TEC. Where different approach control areas adjoin each other, they control a pretty good chunk of airspace. Sometimes it's possible to fly from one airport to another and still stay in approach control airspace. You don't enter a center's airspace at all. In some areas like this, approach control facilities have agreements with their neighbors to give you clearances without having to work through the center. When Tower En route Control is available, you can save a lot of time. Just come up on whatever frequency is being used for clearance delivery and ask for the Tower En route routing you want. You should get it with little or no delay. This can really speed things up when you need a clearance in a hurry. Tower En route control arrangements are found on both the east and west coasts. Since these things are worked out on a local basis, the East Coast arrangement and the West Coast version appear quite different in the airport facility directory. For example, look in the back of the Northeast Airport Facility Directory right after the chart bulletin pages. There are a couple of schematic maps and then a page titled Tower En route Control, TEC. Toward the bottom of the page, you can see Tower En route Control City pairs. The left column lists the city you're leaving, and the far right column lists the destinations you can reach from that particular place under TEC. For instance, if you want to go to Danbury from Albany, look here at the very bottom of the page. The big bold 3 at the beginning references a note which says this route is for prop planes with speeds less than 250 knots. They're talking about the Skyhawk there, right? You would fly from Albany via Victor 123 to Harp intersection, and the approach facility handling Danbury approaches takes it from there. You'll need to read the fine print to get all the details, but you can see the general plan. Now for the left coast version, look in the same place just after the chart bulletins in the Southwest Airport Facility Directory. Here is an entirely different setup. In this case, each approach area is listed, followed by all the possible destinations directly underneath it. You see the routes bundled into a neat code. They are described in the next column over, and then you see the highest altitude you can expect according to aircraft speeds and types. For example, suppose you are in Santa Barbara, SBA, and you want to go to Santa Monica, SMO. You file SBAL6. That will take you to Quang intersection, to Camarillo, to Van Nuys, and then via Victor 186 to Darts intersection. At Darts, the approach control facility for Santa Monica will take over. Again, you'll need to read the fine print for the full how-to details. As you can see, that little green cover paperback called the Airport Facility Directory still deserves space in your flight bag. Fan through those pages and you'll find information that will not only keep your planned flight safe, but make it more efficient too.